I'm seeing some familiar names from other programs and also from Saturday Morning Physics. So it's really awesome to have you back at another event. My name's Amanda Early. I work in the Office of Education and Public Engagement. And it's great to have you at this first live online STEM Career Expo using a combination of Zoom and GatherTown. So we have a couple special guests to welcome you tonight. So I'm really excited that they're available in here. So I'm going to start by introducing Kate Gregory. She is the Chief Operating Officer at Fermilab, and she has a welcome message for you all.
Hey everybody, welcome. It's really great to see your names and some of your faces tonight. I am pleased to welcome you. I'm sorry that I can't, I'm speaking for Nigel Lockyer, who can't be here tonight. He's the director of our lab, but he's on another call right now. And so he asked me to send his welcome. For those of you who have not been to Fermilab, maybe you've visited our website, maybe you've been in Saturday Morning Physics, maybe you've seen the bison, maybe you've read something about Mu-to-E lately, but you know that Fermilab is involved in a lot of things, from the smallest particles to the biggest exploration of the beginning of our universe. And we do a lot of cool stuff. And so we're hoping that this Career Expo tonight will get you excited about the same kind of things that got us excited. I'll tell you that this expo means a lot to me personally, because when I was in high school, I thought I wanted to be an English major. And my mom suggested that I go to a Women in Engineering expo, similar to this, but not on Zoom. And it changed my life, literally. And I went to that expo, spent a day learning a lot about engineering and science and the opportunities available. And it made me completely change what I wanted to do with my life and what I chose to do for college. And for those of you who are at that point in your lives where you're thinking about what do you want to do next and what's the right step for you, I hope that you have the same transformational experience tonight at this expo that many of us have had at earlier points in our career. Now, the expo I went to was a lot more old-fashioned. I walked around a big conference room and got a lot of pieces of paper. And I think the experience you're going to have tonight is going to be a lot more interesting. We've got a really cool panel set up, and the GatherTown opportunity to really look into booths and see the science that's going on and communicate with people is a really rich way to see the kind of things that you can do someday with your future. So I hope that this experience is good for you and that you come out of this as excited as I was after my expo. Welcome, and I hope that we see you here at Fermilab soon. Thanks a lot, Amanda.
Thank you, Kate. And with that, I'm going to turn it over to Rick Verhagen, who is the Department of Energy Site Office Manager at Fermilab.
Hey, thanks, Amanda, and thanks, Kate. That was a nice note. Yeah, this is a pretty exciting evening. An opportunity to talk about STEM, science, technology, engineering, and math, which have been a big part of my life and my career. You know, I have a few math degrees from Purdue University and a degree in nuclear engineering from Penn State University. And because of that, I've been able to spend 24 years in the Navy, serve on a few aircraft carriers, a few submarines, had a pretty enriching career there, doing cool engineering and science type stuff. And then I spent another decade in the Department of Energy's both nuclear safety and environmental cleanup activities. So another great opportunity there. And now here I am, Department of Energy's site office manager at the forefront of scientific exploration. So that is, it's been a real rewarding career, and it all started with, you know, my interest in science and technology, engineering, and math. My youngest daughter, I've always encouraged her to pursue her passions, and her passions have always been fishing and just animals in general. So she actually pursued a biology degree from University of New Mexico. And coming out of University of New Mexico, she got her first fishery biologist job and spent her time in the Rio Grande, either netting fish or shocking fish, or occasionally herself accidentally. But really had a great time there, sitting on the shores of the Rio Grande, watching the nets, and, you know, got to combine her passion with her experience in college as a biology major. I will tell you, it opens a lot of doors. We moved out here recently. I've only been the site office manager for about 3 months now, a little over 3 months. And last week, she decided to come live with us because she wants to, you know, get out of Albuquerque and move over to Chicago. And within just a few days, she already had a job working in a biochemistry lab, just because of, you know, the experience and the education that she's got. So, you know, I highly encourage you to pursue what interests you, and, you know, if you can do that and combine it with a STEM career, that is really awesome. I'd also encourage you to go into GatherTown, go see our bison. maybe do a virtual tour of the muon G-2 experiment that Kate talked about. And you can even walk down our accelerator if you so choose. So enjoy the evening, and it's great meeting you all, and welcome.
Thank you so much for that welcome message from both of you. I really appreciate you being here tonight. With this, we're going to turn it over to our moderators for the evening. We have Sue Sanders and Nikki Meistrick. I hope I said your name right, Nikki. And they will take it away. There are a couple of panelists I think I need to track down in Gathertown because they're having too much fun. So I will turn that over to them.
Hi, good evening. Again, my name is Nikki and I'm a high school counselor, and I'm here with my colleague Sue. Sue, if you'd like to introduce yourself.
Hi, I'm a retired school counselor, but have worked the Fermi Career Expo for 10 years. And this is the second one that's on Zoom. So welcome everybody who is here.
Yeah, Sue and I had the opportunity to do the first virtual one last year. So it's definitely nice to see it be productive and successful. And hopefully we'll be able to see everyone in person soon. So with that, we'll get started. If the panelists can briefly introduce themselves by giving us their names and where they work. Who would like to start? You can use the icon to raise your hand. I don't see any hands, so I'll go ahead and choose. Dr. Tanaz?
Absolutely. Hi, everyone, and welcome to the Career Expo. It's very nice to have you. So my name is Dr. Tanaz Mohayai. I'm a postdoctoral research associate at Fermilab, and I study neutrinos in specific. So neutrinos are types of fundamental particles, meaning that they're one of the building blocks that make up the universe, and they can't be broken down into smaller pieces. They're one of the most abundant fundamental particles, and they can come from the sun, and they can come from the core of the earth, or they can come from supernova explosions, which is when a star collapses in its core and dies. So in fact, as I'm speaking right now, millions of these neutrinos are passing through us, but they're also rarely interacting, so no reason to be to panic. So in a way, neutrinos are basically the introverts of fundamental particles. We have to build big detectors, which are really these cameras and microscopes, and this gives us enough opportunity to see them interact in these detectors. And because only when they interact, we can study them and understand them better, that's one of the reasons we build these detectors. To make it even more interesting, neutrinos they come in more than one type or one flavor. And when they travel a certain distance, they actually switch their flavors, a behavior that we can't explain with our current models. So we need to study them very closely. So I guess since this is a STEM career event, I'm happy to share a little bit about my career path and how I made it into Fermilab. So growing up, I didn't quite picture myself as a scientist, partly because there were, no opportunities to access and interact with scientists in the place that I grew up in. And there were also not a lot of resources for a young kid like myself to learn more about math and science beyond the school curriculum. And the school curriculum was also somewhat limited, but my parents are from a rural area in the southern region of the Caspian Sea. And the night skies there did not much have, light pollution. So they were just so magnificent. And that caused me to become fascinated with astronomy. And because of that, I always paid close attention to my math and science classes in school and did my best to do very well. And
Wonderful. So I just want to make sure we get everyone in here. Dr. Hester?
Yeah. So I am Josiah Hester. I'm an assistant professor of computer engineering at Northwestern University. So that's in computer science, electrical and computer engineering departments. And I guess how much should I dive into?
If you could just go ahead and just, you gave us your name, where you work, and I think throughout the questions, I want to leave enough time for them to ask the questions.
Absolutely.
I'm sure we'll touch on some of the other stuff.
I'll just leave a preview
through
of
their,
the things I
through
do
their
right
questioning.
there.
Of course, thank you so much. Next up, Terry Miesle.
Hi, yes, my name is Terry Miesle. I'm a senior savory flavorist. I work at Sensience International here in Hoffman Estates. My background is food science, bachelor's and master's degrees in food science. I've been doing the Flavorlab ever since, so about 30 years now. Learning what makes food smell the way and taste the way it does, and learning the language of the chemistry behind that.
Perfect, thank you. Mr. Stuart Feinberg? You're on mute, Mr. Feinberg? We're still.
How about now?
There we go.
Hi, I'm Stuart Feinberg. I work for Argonne National Lab. I'm actually in their health and safety department. So I'm on the support side of science. Everything we do in science has hazardous materials, hazardous equipment. There's laser beams, dangerous chemicals. My specialty is chemical safety. And also have background before Argonne that included some emergency response in transportation and other areas like that. I started life as an analytical chemist in QC labs and migrated into safety over the years.
Wonderful. And we'll end with Ms. Sonia Odell.
Hi, my name is Sonia, and I am working with Fox Metro Water Reclamation District. I'm a lab analyst, and I graduated from school and went right to work in Fox Metro and have been there ever since. It's a great career, and I hope you have many questions. Have the water behind me because we at Fox Metro take the dirty water that is flushed from your down your sinks and down your toilets, and we turn it into clean water, put it in the Fox River, in the Tri-City areas, and then we take that water, it flows down the Mississippi and out into the Gulf.
Awesome. Thank you again so much for joining us for this event this evening. So just as a reminder for all our attendees, you can use the chat to submit your questions. We will monitor the chat for your questions. However, if you don't have any questions at the moment, we do have a few to get us started. And for our panelists, I just wanted to let you know that we're going to ask you for a couple minutes to answer the questions, and I will provide you with a thumbs up icon to let you know that we're reaching our limit. That way we leave enough time for our students to answer questions, ask their questions. All right, so let's get us all started. So first question, what is your educational background and how did you come to this career? Dr. Mohayai?
Absolutely. So I had some mention about this, but my interest started, through astronomy and my fascination with math and science. I guess everything starts from the point where I moved to US. So when I first moved here for a while, I didn't quite think that pursuing a career in science was possible for me, as I was basically adjusting myself to a new home and being a first generation immigrant. When I went to college, my parents, to some extent, expected that I major in something that was practical and could lead to a job quickly. But again, I couldn't quite let go of my fascination for math and science. So I majored in physics with a concentration in astrophysics. which is really at the interface of astronomy and physics. And I think the point where I really realized that I'm pursuing science as a career, no matter how long of a process it might be and how much challenge or obstacle it would present in my path, was really thanks to one of my mentors during my undergraduate years. Just to emphasize the importance and the power of mentors and representation, this was Dr. Christina Kadavik, the name of my mentor. And from that point on, I followed what you can call as a non-traditional path into my PhD at Illinois Institute of Technology. I took roughly a year and a half after my undergraduate degree to do research in particle astrophysics first, and then I applied to graduate programs, and I got into a program that I really wanted. And then as a PhD student, I also applied for the Department of Energy Office of Science graduate student program, which is how I basically found my way into Fermilab for my PhD research. And back then I was working on muons, these other fundamental particles. And the idea was to use muons as in high energy accelerators to produce more neutrinos, because the more of them we have, the more likely they are to interact in our detectors. And fast forward to now, you know, I find myself at Fermilab, and my area of research is now experimental neutrino physics.
Great. Dr. Hester, would you like to take that question as well? Educational background and how did you come to this career?
Yeah.
Again, 2 minutes.
Yeah. So I got my bachelor's and PhD at Clemson University, which many know for an outstanding football program.
Had to get that in, huh?
Always, you know, go Tigers. And for some reason, even now, people think I played on the football team, but you know, when they meet me, but I think those people have never met actual football players, but I digress. I was early on very interested in building, you know, so what I do is I design, you know, tiny computational things. I'll show a little picture here. So this is a battery-free Game Boy. This may be, you know, a little too old for many of you on the call, but this is what I grew up with playing instead of like the Nintendo Switch, you know, Xbox, PS5, is it now? Jeez, man, I'm old. This is actually something we built ourselves from scratch, and it is powered completely by the energy you produce from your thumb. So every time I click a button, I generate energy that paints the screen. And that's some of the kind of things we do. We also build smart face masks that are powered by your breathing and can hear your heartbeat. Basically Internet of Things type devices that leverage this newfangled thing called machine learning and data science to interpret, you know, data and signals that are just very complex and hard for the human to understand, then use computers and machines to kind of figure out what these signals are telling us. And that's actually applies to Internet of Things that I do, but also to particle accelerators and people that we work with at Fermi. And so I went from my PhD, right? I really went down that path because I was interested in how I could make a difference in my own community. And I'm Native Hawaiian, so indigenous, and we have very few opportunities to increase our education. Basically, most schools in Hawaii are dropout factories, and that's really, you know, kind of hard to overcome. So I was like, how can I make a difference here? How can I gather the skills so that I can, you know, be at the top of computing and computer science? And eventually, you know, I was able to secure a job at Northwestern and start doing work and start a lab here. And yeah, that's kind of the background. That's the story.
Awesome. Thank you so much. Mr. Miesle?
Hi, yes, I have a bachelor's and master's degrees in food science from The Ohio State University.
All right, here we go again.
So I came to it a little bit differently. I was always interested in the natural world and became very interested in chemistry and biochemistry. Thought that's the way I would go. My dad, who was a brilliant chemist, would bring home trade magazines, and I'd dig through them and found food science through Food Technology magazine and said, tell me about this. And he said, well, read about it. So I started reading about it. Became apparent that I didn't have to specialize in anything. I could study microbiology, biochemistry, chemistry, business, engineering, everything as part of food science. You have to know all of this stuff. Ironically, I became one of the most specialized fields in food science, and that's flavor chemistry. There's maybe 300 and some of us in the US, and maybe about 12 who do the savory side of things that I do at my kind of level. And that focuses on not the sweet stuff, but the things like meats, flavors, cheeses, that sort of thing, anything that's not sweet, essentially. So all of the meatless products you see out now, they rely very heavily on the flavors industry to make them taste not terrible. And really, there's a whole side of that that is making it taste not terrible, blocking the bitterness that comes from these proteins and all this sort of stuff. So that's, I don't get involved in too much of that. That's pretty heavy duty chemistry based on how our taste buds work and such, and interfering with those things. I'm more interested in the volatile compounds. I grew up in the kitchen, so I'm very much interested in what happens as foods cook and all the reactions that happen among all those chemicals. Remember, chemistry is a language. It's what we use to describe the physical world around us, all the molecules, all the compounds, and all the interactions of those.
Perfect.
I don't know if anything else. All right.
All right, we definitely have more questions coming through. All right, Mr. Feinberg?
Yeah, so I have a bachelor's in chemistry, and at the time I got done with my bachelor's and went right to work, was kind of burnt out on school and went into quality control, and I became very interested and liked working with things like gas chromatographs and HPLCs. And way back then, gas chromatography was a little bit fun because you made your own columns and you had to condition them. And, you know, if you actually got a peak on your readout, you were like jumping for joy and all excited you did something. Now they're kind of prepackaged and high tech, and you put them in the machines and they always work. But in the course of doing that and being involved with FDA, it was Walgreens Labs. We made at that time the label name products for Walgreens. So we worked on cough syrups and toothpaste and the mouthwashes. So, you know, the assays we had to sign off on for things like that, it's things people are drinking. It wasn't prescription drugs. That's another level of control. But over the years in that, and then after that company folded, I went into the hazardous waste, also doing analytical chemistry with gas chromatographs. Got more and more involved with the laboratory safety. Walgreens, the first QC job, we had things like several fires, and I got involved with the fire extinguisher training programs, and that was my first introduction to chemical hygiene plans. And then at one point, I just went into safety full time, and I worked for a synthetic organic synthesis company that worked for the pharmaceutical industry. And basically, we did scale up work and high hazard work. So
Awesome.
that's where I got into emergency response and all the various you have to be a toxicologist, industrial hygienist, a little bit of everything in a company like that.
Understood.
And now at Argonne, I'm their chemical hygiene officer. And I work with their work planning and control, and I get to work with all the scientists designing their projects and reviewing the existing projects to make sure that they're meeting both the regulations and the actual safety.
Awesome. I want to make sure we have enough time. Ms. Odell, and then we'll get to a couple of the student questions that we have here. We've got about 10 minutes left, so we want to make sure we get our student questions in.
I'll try to keep it succinct. So when I was growing up, I was a military brat, so that means I traveled all over the world. One of the places I lived in was Okinawa, which was a very small island. And while I was there, they underwent a severe drought. The only way they got water was from rainfall. And so the Army actually had to bring ships in to carry water into the bases. We had to ration it. And I really learned kind of the importance and the value of water then. We just can't take it for clean water, readily available. We can't really take for granted. And I was the type of kid that grew up wanting to be either artist or science and anything that was just cool. curious about the whole world. So when I got out of went to school, I went to chemistry because it had very cool color changes. And then once I graduated with the BS from Beloit College, I then joined Fox Metro because I felt impassioned about what they do with the cleaning the water. And I want to make sure all of us have time to get your questions answered. So so hopefully some of my further hints and suggestions and tips will come out in those questions.
Awesome, great. So the first question we have, and if anyone wants, not necessarily directed to any one person, so if you'd like to answer, just go ahead and use the icon of raise your hand for our panelists. That way I'll know who would like to take the question. So the first question is, what advice would you give to a high school student who loves particle physics on finding resources and opportunities? Panelists, just raise your hand in the icon and let me know, or just raise your hand and I will call on you. Anyone want to take that one? I don't see any hands being raised. You can just raise your hand or use the icon if anyone wants to take that one. No? All right, we'll move on then. Oh, go ahead.
Oh, not a particle physicist, but what I would suggest would be try going and maybe reaching out to some of the people at Fermi, contact when you're out talking. Definitely ask for websites. See if you can set up a phone interview or a Zoom chat interview where you're given 5 minutes and ask them about what their average day is like and things like that.
Awesome.
Yeah, I'm sorry about that. I was looking for my unmute button.
Okay.
So I can answer, as far as day-to-day activities, as far as reaching out to Fermilab, we have internship programs, we have mentorship programs, and if someone is also curious about, what day-to-day activity for example, someone in experimental neutrino physics looks like, from my own experience, the idea is we build detectors to collect data, and then we analyze the data. And all of that involves a great deal of not just particle physics, but also statistical analysis, computer programming, electrical and mechanical engineering. I guess to name a few of topics that as a physicist one learns about, but to also name experts from other disciplines that with whom we collaborate. And the whole process of building these detectors, we also build smaller prototype detectors, just to understand how well these detectors can perform once we build them. So there's a lot going on, and there are various ways that students can get involved through internship programs, and they can always reach out.
Awesome. Great. Awesome. So we had a question that was, how essential is machine learning and CS in each of your jobs? And Dr. Hester did respond, saying that it was very important for his labs. He said we have a lot of data and machine learning that lets us figure out how to interpret it. He did caution, however, you have to be careful because these ML techniques can be very biased. One of our participants had asked how much of food today is improved by that industry, and that was directed toward I believe it was Mr.
Yeah.
Miesle and the flavor.
Miesle, yeah.
Miesle, sorry.
Yeah, almost everything is flavored to some degree, and that it's a really, really broad definition. Everything from just spices and their extractives to something that's fully compounded, like a soft drink. Now those are artificial and natural, or increasingly just natural components now. But they could be anything from citrus oils to what I do, which would be taking things like yeasts or meats, stocks, sugars, and other components, and mimicking what happens when it cooks and bringing that into the food. Now, obviously in the vegan food area, that's really important if you wanted to taste something like meat. It's also important in areas where you cannot do the same sort of processing, something that's like very high temperature or dry cooking that doesn't work well in a food plant, they would come to us to help fill in some of the gaps. And that's a lot of what this is filling in the gaps. The example I use most is, say, add some strawberry jam to plain yogurt and it tastes like strawberry jam and plain yogurt, which is not what Dannon or somebody wants to do. So they want their own signature strawberry flavor. They'll still use that fruit preparation, but then we will provide that signature sort of product for them, working with them to do that. But it's everywhere.
Awesome. Dr. Hester also did alerts. I just want to make sure participants notice that if you want to learn more about his lab, he has put a link for you to take a look. And he also identified a recent project that is available on YouTube. Again, that link is in the chat. Dr. Mohayai, the question is, I was wondering how you continuously engage yourself in a set subject of study. Do you ever wish you had a larger scope, or do you think a lot of set subjects have much more to explore than a lot of people think?
Yeah, that's actually a very good question. One thing that I can share with regards to this is, I guess it's really an answer to the question of, for example, how the expertise and the skill sets that you learn in particle physics can, I guess, to some extent benefit society and can directly help. So the particular project that I could share with that is basically a volunteer work that I, along with a group of my colleagues at Fermilab and around the world, volunteered on. It was really with respect to respond to the pandemic. So we used skill sets that we acquire from particle physics research that we do to help with shortages of lung ventilators. And we designed a mechanical ventilator called mechanical ventilator Milano. That's basically low cost. It has a simple design and it's reliable and robust and can be mass produced quickly. And ventilator is basically a machine that breathes for people who cannot breathe on their own. And just as an example of how you can make use of your skill sets, so for example, in the particle physics research that I work on, and neutrino physics research that I work on, we have a prototype detector, which is basically a vessel, and we deliver the noble element argon in a form of pressurized gases, argon, into a vessel. And in order to do that, we do a precise control of pressure, volume, and flow of the gas that we deliver. And this, as we learned, was similar to how a ventilator can deliver air into the lungs of a person. And also in our neutrino physics and particle physics work, in order to study the data that we collect, we have some elaborate data acquisition systems, and we collect the data, we analyze it, and present our findings in some graphical form, which was not unlike the ventilator work. So the ventilator collects information about the delivered pressure, volume, and flow, and it would plot it as waveform to the user, which are the medical doctors on the other end analyzing it. But something that I have to emphasize is that because in the case of the ventilator, we were designing something for use with humans, the stakes were very high. And as particle physicists, we could have not possibly taken on this quest on our own. And we worked with an interdisciplinary team, and we had to find common language. So for me, this meant learning about the work of other team members from other disciplines, such as, for example, understanding the basic functions of our lungs. It was overall very humbling experience because I truly understood what it means when we say we do great things for society, when many people from various backgrounds and disciplines collaborate with each other, and we also expand our horizon in other STEM fields. So I guess
Awesome.
For example, we have this STEM event right now, and we're learning from each other, which has really been great.
Awesome. Yeah, we have actually come to the end of our time. It is 6:50, but I want to thank our panelists for joining us today and all of our participants. It's been awesome. Thank you so much.